Tanmay Bunkar from BotLab Dynamics. So let me just give a brief introduction about Tanmay. So Tanmay did his graduation in engineering physics from IIT Delhi, and he has been working on drones since his first year at IIT Delhi. So his primary focus was to make drones more capable as a system and then networking them for greater effectiveness in numerous use cases. With this, he founded BotLab Dynamics with his colleagues, and the team at BotLab since then has worked on indigenizing the technology that is involved in making a drone, along with solutions to enable flight of numerous drones together. So currently they don't need much introduction. So with this, I would like to hand it over to Tanmay. Over to you. We can begin with the talk. Yeah. Tanmay, you are not audible. Please unmute yourself. Yeah.
Okay, I would like to share my screen if you can give me just the permission for that.
Sure. Go ahead.
Yeah, so where is it? Okay. How do I share my screen by? Yeah. Share content. Just 1 second. I'm just sharing my screen. Where is it? Where is it? I hope you can see the PPT now.
Yes, it's visible.
Okay. So just to start with, basically the objective is to make the drones fly together. So they are flying in a certain formation and making these 2D and 3D shapes in the sky. So this is a subset of the technology that we have built over the years. Initially, we started by just putting together components. So you will take a flight controller, you will take those subsystems, motor, propeller, batteries, frames, and you will put it together. And then basically make the system work. Now, a system made in such manner is limited in very many respects. It will not fly for longer. It will not take much payload, and also that anybody else who has the capital to buy those parts can put a system together, and then you don't have any advantage over anyone who chooses to do so. Okay. Keeping that in mind, we realize that a single system might be limited, but if you have a number of these, you can address other problems that might not be addressable by a single drone. Apart from that, when you network these things, you also are making sure that the probability of failure, let's say if you have a big system and that system fails, your mission is jeopardized. You cannot from that point onwards address the problem that you were supposed to solve. So when you have multiple systems, even if a few of them fail, you can still carry on and accomplish your task. Okay, so we started off by swarming drones together. So the picture that you've seen in the background is from 2019 when we flew 10 systems at Manekshaw Center. So this was the very first demonstration that we did to the Indian Army, where all of these drones were talking to each other and they were able to relay information. So there is one of the drones which is broadcasting its location, and the others are keeping a relative position from that particular drone. So this was this particular system has a hierarchy where you have one drone which is the master, and then others are following by a predefined relation from the drone. So it could be in a circle, it could be maintaining a certain distance only. All of that you can have pre-programmed on the drone, and you can select what behavior is to be demonstrated on the fly. So all of them are talking together, and if you can address any one of the drones, you can actually address the rest of the swarm. After that, we started working with the Air Force. So there was this Air Force competition where we were supposed to demonstrate 10 drones flying together, going 5 kilometers with a kg payload each, identifying a target and then servicing that target. So the application there was to address the problem of humanitarian aid and relief in situations where there's flooding, in case of a natural disaster. So where drones can be used to address a problem, and this was a problem tailor-made for drones because flying by nature is expensive. You should not fly to a place unless there is any other option. A ground robot can go from point A to point B in a much efficient manner. It will consume much less energy, whereas a drone has to support its own weight at all times. So you use a drone only when you have a very time sensitive application. You have a very time sensitive need. So that's why the Air Force conducted this exercise where they invited a number of groups from country to demonstrate their capability of servicing a target using drones. Unfortunately, when we went to Pokhran with our systems, which are working perfectly, and we had tested in Ghaziabad, we went to the Indian Air Base. So the Air Force was very, very helpful in providing us the Indian Air Base to test out our systems. Everything was working fine, but once we went to Pokhran in the heat of the desert, and because of the first time we were transporting these systems from Delhi to someplace else, our systems failed. We were not able to take off, and then we realized that you cannot go forward just by putting systems together. You cannot go forward just by buying hardware off the shelf, assembling them, and then thinking ki this will work. Because if any of the systems fail, you cannot repair them. It is not repairable, and it is not, your maintenance is also hampered because the parts might not be available readily or might take some time to get to you. That point onwards, we realized that we have to build our own flight controller, build our own electronics at least, because that amounts to about 50-60% of the total cost. We demonstrated the same drones demonstrated it at an army base in Udhampur, and then we went to Sri Ganganagar also. So we were demonstrating all of these technologies where all of the drones were working together, they were communicating, exchanging data on the fly. But then we realized that a subset of this technology can be used, and that will make much more commercial sense. And that is when we saw that Intel was doing these shows. So on your screen, you might be able to see that there is a globe made with around 1,000 drones. So this demonstration was done by Intel. And this was the moment where we realized that this will make a lot more commercial sense if we can put a similar show together. Now, we realized that the technology was very deep, and there are certain aspects of the technology that we need to master before we can do a show like this. The very first was to make your own hardware, because that will let you bring the price down. Because when Intel is doing a show like this, they will charge in the neighborhood of $100,000, involving 200 drones for a 5-minute show. So 80 lakh rupees for 200 drones flying for 5 minutes. And there is a lot of interest in the market for product launch and like an event launch. Wherever you want to grab the attention of a lot of people in a very short span of time, a drone show might be the way forward. So then we started that once you make a drone, the story doesn't end. Making one single drone was easy, but how do you make it replicable? How do you make them in a manner where you can ensure the quality of these systems. So all the 1,000 drones in your fleet behave in a predictable manner. For that, we started off by building the flight controller. So the flight controller was the very first part that we made. It was also the most challenging of all the parts. And it gave us certain confidence that yes, we can put something together in a short span of time and then qualify it on the bench, then put that thing on the drone, fly it, qualify it in flight, and then make a number of copies of the same system. After that, we started working on the GPS. The GPS was especially tricky because this is a very sensitive device. Any small irregularity will throw your GPS solution, your localization solution off by meters. And when you're flying in formation and the drones are just a few meters apart, that error is not something that you can tolerate. So we started working and the GPS was the next biggest task that we handled. After that, I hope you can see it on the screen. We were working heavily with controls. So we made our own motor controller, and this was the very first time that we tested it with a motor. And hopefully you can see the motor is spinning on the screen. And we were able to give it very jerky movements, and we were able to see that yes, not only the motor is spinning, it also, as the doctor, not only the motor spins, we can very rapidly introduce throttle changes, and the motor was able to, the controller was able to get those changes reflected in the speed of the motor. The flight controller, though we have flown this particular system on our small drones, our 250 nano class drones, but the same flight controller is used on a bigger system. So again, hopefully you can see on your screen, there is a drone around 3 kgs of weight, and it is flying.
Tanmay, your voice is breaking. Sorry to interrupt.
I think it is because of the video.
Yeah,
I will, I'm sorry, I will mute the video and then. Can you hear me now?
Yes, yes.
Yes. So what you can see on your screen, hopefully, is that this particular system weighs around 3 kgs, and it was able to, the flight controller was able to fly the drone, which is 10 times of the spec that we originally designed it for. Oh, my PowerPoint crashed. I have to share it again. 1 second. Probably at this point, I will show you a picture. Can you see the video on your screen?
Yes.
Yeah. So what you see on your screen is the takeoff of 1,000 drones from the forecourt of Rashtrapati. Hopefully you can see I have some disturbance at my end. But what you're seeing is 1,000 drones have taken off, and then now they're putting in themselves into position, and there are certain flares of light going through the formation. And then this was the very first formation that we did on beating retreat. So these are 1,000 drones, and as you can see, they are making a globe. So the globe was a particularly challenging formation for us because first of all, it's 3D. Second, that you have to have your drones positioned such that you can see those continents, you can see those land masses. And not only is this thing 3D, it was also rotating about its axis. So having all of those drones moving together, having that solid rigid formation was particularly difficult. And just we started off with that formation because we knew that this would be particularly challenging. And your very first formation should showcase what is the extent of what is the limits of your technology. I'm coming back to the presentation now. Sorry, it crashed in the middle. So in order to fly that tight formation, your GPS has to be very, very accurate. So this is our GPS. This is a quad band solution. We can digest data from Beidou, GPS, Galileo, and GLONASS simultaneously. So on a normal day, L1 GPS or just a GPS which will support only the GPS satellites, you will get a lock on around 15 satellites on a good day. Whereas our system, we used to regularly lock on to 30 plus satellites. So we have logged on to 42 satellites at best simultaneously, and they're practically all the satellites above the horizon. So we were able to detect each and every satellite that was above the horizon. Again, the system is has a hot start capability where it can start up so it will get you a localization solution in less than 10 seconds. We have integrated an amplifier, a GNSS amplifier on the circuit board, and we also have this RHCP, right-hand circularly polarized antennae on the GPS module, so you have excellent signal rejection. So basically, if you have multipathing, so if the satellite signal is reflecting off of a structure that is close to you, that particular signal is rejected. We also have a SAW filter, and the system, the solution that we get is around 10 centimeters. Now, if you compare it with a GPS that is available off the shelf, that has an accuracy of about 2 to 5 meters. So we are 20 times more accurate compared to a normal off-the-shelf solution. Primarily because this GPS has RTK built in, so real-time kinematics, wherein you are sending corrections to the module, so it can enhance the accuracy of your positioning solution. So how that works is that we have a base station. So a base station will conduct a survey. Basically, it will receive data from all the satellites that are going above. It will come up with a localization solution, and it will fit that solution in a Gaussian curve. So if you have enough data, let's say 8 hours or 24 hours worth of data, you can fit that data to a curve, figure out the center of the curve, and as the base knows that it is not moving, once you take it out of the survey mode and you put it in the correction mode, it will start spitting out corrections. So your solution might say that you are 2 meters north of your actual location. The system detects this error, and then this error is transmitted to the rovers. In our case, every drone is a rover. So all of them gets the same correction broadcasted on a sub-gigahertz link. And off of that, each and every drone knows that I have to put this correction, add or subtract this correction from its own solution to enhance the accuracy of the system. So that's how we get this sub-meter accuracy. Now, this particular technology has applications beyond a light show. You can use the same GPS on a precision agriculture drone where you are using it to spray fertilizer or chemicals in a field. Or you can do it, you use it in surveys where you want to geotag your images. So the better precision you have in geotagging those images, you will get better results, because now the error associated with where that image is taken from has gone down 20 times. So you will be better, you will be able to stitch those images together better. Now, in order to fly those drones, you, as I said, you have to send corrections. So we have a sub-gigahertz model, as I said. What you see on your screen is a waterfall from a spectrum analyzer. Because we were operating at Rashtrapati Bhavan, and there is a lot of security apparatus that is put put up around that vicinity, we were told that you have to do a spectrum survey, a RF survey. So we conducted an RF survey, and we were able to detect what are the frequencies that are operating in the general vicinity of where we were flying, and also guarantee the security agencies that our operation will not in any way hinder their operations. Because there is a lot of walkie-talkies, they have this CCTV cameras, they have other wireless equipment around, and we were able to make sure that our operation does not coincide with anybody else